All right, for 1.3, the second part that we're going to do here, we are going to focus on two concepts. The very first concept is to be able to solve equations, and the type of equations we're going to do are literal, okay? And then the second thing is we're going to talk about the quadratic formula. All right, so the first example here when we talk about the idea of literal equations is basically what we want to do is we want to take the equation that is given and we want to rewrite it so that it says y equals. So whatever it's asking for, whatever letter, that's the letter that you want to try and get by itself. I'm starting off with this example because basically what it wants us to do is to take this equation and rewrite it into slope-intercept form. So if that, triggers a memory in terms of what to do. All right, so the very first thing I would see to do is to subtract 3x to both sides. I'm left with a negative 5y equal to a negative 3x plus 22. And then I'm going to divide everything by a negative 5. And when I'm done, I got y equal to a positive 3/5 x and then minus 22/5. And notice I now have the equation written in the form of y equals. All right, not really much in terms of notes. If I were to talk about notes, I would basically talk about the idea of PEMDAS, okay, in terms of order of operations, and that when you're simplifying, you go in this direction, but when we're solving, you actually go in the opposite direction. So case in point is example 2. Our goal is to get the a by itself. So that means that I am looking to add or subtract first. Well, since I'm subtracting an x here, the first thing I'm going to do is I'm going to add x. And now I've got a y plus a over x equal to a z plus x. So it looks like I added. Now, to get rid of this x that's in the denominator, I need to multiply it out. So I'm going to multiply by x to cancel it out. And that means I have to multiply the entire right side by x. And so therefore I've got y plus a is equal to z plus x times x. So it looks like I did my multiplying, right? Now you would say, okay, well, you were going back to adding or subtracting. Technically, we're up here at parentheses, and the reason is because when you have something that is being added in or subtracted in a fraction, there's an invisible set of parentheses, and that kind of just follows along here. So therefore, now what our objective is to do what's inside the parentheses, and that is if I want to get the a by itself, I am going to subtract y to both sides. And so now a ends up being an x times a z plus x and then minus y. All right, so just something to think about in terms of when we're going to solve, we want to go in opposite order of operations. All right, in example 3, our goal is to get the z by itself. All right, so first thing, number 1, some people think, oh, I should distribute. Well, you don't really want to distribute, and the reason is you already have a single with z. If I distribute that 13k, now I got 13 z's, okay? Instead, I want to do the opposite, and since I have a 13k multiplying by the parentheses, I am going to divide by my 13k. Some people think subtract, but we're actually dividing because of the distributive is multiplication. So n over 13k equals 1 minus z. Now to get the z by itself, I'm going to subtract 1 to both sides, and I've got n over 13k minus 1 is equal to negative z. Don't forget about that negative. So to change it into a positive, I got to divide everything by a negative 1, and now I've got z equal to a negative n over 13k, and then negative 1 divided by negative 1 is plus 1. All right. Example 4 here, our goal is to get the b2 by itself. Okay, so therefore, in order to get the 1/2, some people think about dividing by 1/2, but since I'm already kind of dividing by 2 because of the 1/2, I'm going to multiply both sides by 2. So that gives me a 2a equal to a h times b1 plus b2. I'm going to divide by h, and that's going to give me an 2a over h equal to b sub 1 plus b sub 2. And now I'm going to subtract the b sub 1 over, and I've got b sub 2 equal to 2a over h minus b sub 1. Okay? So please just make sure you understand the concept or the directions in terms of whatever letter they're asking for, that's the letter that they want you to get by itself. All right, part 2, quadratic formula. So if you recall, the quadratic formula is used to solve a quadratic equation. It can be used anytime, okay? We've already talked about the idea that you can factor to solve. So you can use the quadratic formula even if it's factorable, but ideally it's used for when it's not factorable, okay? I'm going to sing it for you to help you remember. So remember, x is equal to the opposite of b plus or minus square root b squared minus 4ac all over 2a. All right, where does that come into play? That comes from the idea that ax squared plus bx plus c equals 0. A is the coefficient of your x squared or quadratic term. B is the coefficient of your linear term. C is your constant. And you must set it equal to 0 in order to do this. So taking a look at example 6 here, the first thing I'm going to do is subtract n squared to the other side. I'm going to add the n to the other side, and I'm going to add the 7 to the other side. So 4n squared minus n squared is 3n squared. I got my negative 6n. When I add an n to that, I get a negative 5n. And then when I add the 7, I now have 0. So now I can say that a is equal to 3, b equals negative 5, and c is equal to 7. All right, so just make sure you understand you got to set it equal to 0, and then you got to be able to identify the a, b, and c. After that, it really just comes down to plugging in. The only other thing that I'm going to talk about is, because we're dealing with a radical here, is if you ever get the square root of a negative number, remember that we're not using the idea of I, so therefore we would end up saying that there is no solution. All right, let's go through an example here. Okay, so I see that it looks like my A value is going to be 1, my B value is going to be 5, my C value is going to be 8, and since it's already set equal to 0, that's how I was able to determine those things. So x equals the opposite of b, negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. After this, it just comes down to order of operations. So negative 5 plus or minus. I have to do everything inside of the square root first and do the square root last. So 5 squared is 25. 4 times 1 times 8 is 32. And then 2 times 1 is 2. So it looks like I got x equal to negative 5 plus or minus the square root of negative 7 over 2. And like I just mentioned a few seconds ago, since I'm taking the square root of a negative number, I am going to say that there is no solution here. Right? And that's quadratic formula. Really big thing on this is just, take your time with it and make sure that you are just following order of operations, especially on the inside of the radical. All right, let me know if you have any questions.